So in forecasting, we begin with the time series. And in the previous video, um, I showed you that there were ways to smooth the time series. So we would have a time series that would have, a number of entries here. These are measurements as we step along those time periods. And then we smoothed it, with say a 5 element moving average. And then we had a new series. So if this was 5, it would start here, right? And so we would have a smaller series that would smooth out all the peaks and troughs of the original time series. And we might also have an exponentially smooth series, which would have a different series of values here. And so one way of using these smoothed time series is one way to forecast with these new series is to just say, okay, well, my new forecast of my forecast of the next period is just going to be this last entry. Okay, so you've taken your time series and you wound up with, let's say, sales of 32 million. So this would be your forecast for the next time period. Okay, and likewise, if you had a smooth and you wound up with E sub I was equal to 5 million, then your forecast would be just that value. Forecast is 5 million. Okay, so the idea is that once you've smoothed out this time series, you have within those averages, or those that exponentially smooth series, you have all of the various patterns that go into the movements of the time series. So that will be embodied in this last one, so you could just pick that last one as a good prediction of what the next period is going to be. And what we're going to look at today is we're going to be using regression for forecasting. We're going to get a little bit more sophisticated than just taking the last elements of a new time series, and we're going to use regression, and where we're going to make our dependent variable is going to be the measure itself, and it's going to be a function of a certain number of x variables. Okay, so it's going to be a function of time, but as you'll see that there are several indicators that can go in here to designate time. Okay, because in here this vector of x variables needs to include any trend, and it needs to include any seasonality. And what we'll see is that this will just be a sequence that just a generated artificial sequence that runs from 0 up to however many periods we have. And then the seasons, these are going to be dummy variables, which we looked at before. Okay, dummy variables for each quarter. Okay, so let's take a look. So the simplest form of regression that we can do is just simple linear regression, SLR. And we had we spent a few days on that, and that's where we are predicting some dependent variable on the basis of a single independent variable, and our objective is to get back a slope and an intercept. Okay, so we start with our our actual time series here, and the first thing we do is we assign a sequential numbering. Okay, and then we just make this sequential numbering our independent variable, and this our dependent variable. Okay, so for example, if we were to now that we've got our x here and we were to regress y on x, we would get back this kind of equation. Well, so how do we use this to predict? Well, all we have to do, remember that this is our x, so all we have to do is plug the last, the new time period into the equation, and that's our new x, and that would give us back the forecast for that period. Okay, so that would be 79.33 right there. Okay, and so how do we know if this is going to be adequate? Well, we might, you know, a good practice is to always take a look at your time series to visualize it. And so if you look at your time series and you appear to have something that, points that fall along a line pretty well, then a linear regression would work for this. And anytime you're thinking of doing a regression, a plot is a good place to start. So we're going to do that. Okay, so I have here Walmart revenue data from the first quarter of 2008 up to the fourth quarter of 2012. Okay, and what we're going to try to do is to project. We'll pretend that it's only the fourth quarter of 2012. This just happened to be where my data stopped, and we're going to try to predict the next. Let's see. Stay consistent with my coloring here. So I want this to be the calculated value. Okay, so we'll say okay, calculation here. So the idea is our next, the next quarter is going to be 2013, 2013, and based on this numbering, it looks like 1, 2, 3, 4. It looks like it's going to be a first quarter. Okay, so this is what we are trying to predict. Okay, and so we're going to try, simple linear regression first. So of course, where do we start? Well, we start by looking at the data. Okay, and we're going to insert a line chart. Okay, okay. So we can see what this time series looks like. Okay, now this is revenue, so I'm going to go ahead and title this so I remember what we're looking at. And this is it kind of squeezed everything in a little period here. So I'm going to format this axis. So I'm going to click over here and right click and do format axis. And then instead of starting at 0 and having all this white space down here, I'm just going to change that to 80. Okay, so now we have a little bit better of a picture of what's going on here. Okay, and we see, okay, so we see that there is a trend. There's probably a trend in there. And I'm going to select there and right click and add a trend line just to see. Okay, so it looks like there is a long-term trend and it slopes upward. So if we were to draw a line here, this would be a very helpful thing to use to predict. Okay, if it's been going up, then our prediction would incorporate that awareness. Okay, so we'll deal with all of these peaks. Clearly there's a seasonality here. So this is first quarter, second quarter, third quarter, and then fourth quarter jumps up 1, 2, 3, 4. So it looks like every fourth quarter we have a major jump, and that would be the holiday shopping season. Okay, so let's start off by achieving this line and then using that line for a prediction. So what we need to do is we need to create our time periods. So this is going to be our our t, and we're going to start the numbering at 0, 1, 2, 3, and then we'll have Excel finish that numbering all the way down. Okay, so this number will be our independent variable. Okay, and this, you see, these were put in here on the x-axis automatically. Okay, so this will be our x and this will be our y. So we're going to try to predict revenue based only on time. Okay, so let's go ahead and do data analysis and regression. Okay, so our y's are revenue, and our x's are this sequential series that we created right here, their sequence. Okay, And let's see, I believe I got the labels. Okay, and yeah, we'll just keep it at that for now. Okay, so this is pretty good. You see we have an R square, and 0.64. So we can predict with just a linear trend 64% of the variance in revenue. Okay, it's pretty good. Come down here, we can see that we have an F of 39, pretty good, and that's less than a 0.05 significance, so the model is good. And we see that this, it's kind of hard to read in scientific notation here, so I can just make this numeric and just keep expanding it until numbers start to appear. So this p-value here, we see that that t time does make a significant difference in the revenue. Okay, so this p-value tells us that. Okay, so that's the p-value for the t statistic. Okay, so we have here a pretty good model that we can use to forecast the next period. And so how do we do that? Well, we just as always, I'm gonna lop off some decimal places here, maybe just for these so that you can read them better. Okay. All right. So what's our linear model? Well, so our linear model is going to be if we have our x's over here, and this is going to be our prediction. So our prediction is just the intercept plus the slope times whatever your x is over here. Okay, so that'll be our prediction. Now notice that we don't, x is equal to 0 right now, so it's just exactly equal to the intercept. But if we were to put an x in here, so what x would we be doing? We are trying to forecast, it looks like the next period is 24. So we would just put 24 in for this x, okay? And so under this linear model then, our prediction is 119.1, okay? So we'll put that in. We'll put this in as our, we'll note that this is our linear prediction. So this line is going to stretch out to the 24th period, and it's going to hit the y-axis. Its y value is going to be 119.10. Okay, so this is our linear prediction. Okay, now it's always possible that your time series doesn't actually follow a nice line pattern, so you might have to take into consideration that you have curves in there, and so a curved model might fit better. So what do? Well, we add a squared version of the independent variable into the model. So we do a multiple regression on both the time period and the square of the time period. And then we just compare the adjusted R squared to see if we've done any better. Okay, so let me explain that in a little bit more detail. So if we believe that we have a curve, and just one curve in our time series, then we might consider a quadratic trend model. Okay, so remember that in the linear case we only used this part of this. Okay, so now what we're going to do, and remember that this was just the time period. Now we're going to be adding into this the square of the time period. And what this will do is it will accommodate any curvature. So when it estimates the coefficients, it's going to take into consideration any kind of curving. Okay, and so when do we try this? I mean, when do we suspect that a line is not going to be enough? Well, if we have a time series that looks like this, where it goes up and then there appears to be some kind of maximum, okay, or if it curves down and there appears to be some kind of minimum right here. Okay, so if we have this frowny face or this smiley face, this should cue us in to the fact that we're looking at a quadratic trend, and we need to add an x squared into our model. Okay. Now, we didn't really observe this in the Walmart revenue data, but let's go ahead and add the square into the model just to see what happens. Okay. So we're going to, I'm going to move this out of here because I need this column. So now this is going to be t squared. Okay. So I'm going to take this, and then I could square it, or I can just multiply it by itself. Okay, same thing. So now I'll take that and copy it down. Okay, so now this is t squared. If there is any kind of like curvature in here, now this will be a better fit for this trend. So let's see. Let's see if it does any better. So once again, we're going to be predicting 2013-1. So it's the first quarter, and it's period 24 again. Okay. All right, so we're going to put this here as our objective for what we're going to calculate. Okay. All right, so let's do a new regression now where we put both of these in there. Okay, so we'll do data analysis regression. Okay, y is the same. Now we're going to take both of these as x variables. Okay, and I think I selected the labels, so okay. Okay, no, I didn't. Okay, y is revenue. Okay, that looks good. And x, probably didn't select that correctly. Oh, I went down too far. Okay. Okay, now let's take a look. So remember that when we have multiple independent variables, we should be looking at adjusted R squared. Our adjusted R squared went down, so this is actually a worse fit. You know, it's still significant. We look at the p-values. Now, the t statistics are pretty small because we have large standard errors in here. So, you know, this model, now when we have both of these in here, we can see that that neither of these is significant in predicting. So that's why our adjusted R squared went down. Okay, and we can see that, you know, the reason why the coefficient changed for the t variable is because of, you know, collinearity. Obviously, it's going to be correlated with the t squared. Okay, so this is not a good model to have, and so we're not going to try to use this to predict. But if we did, all we would do is you know, do the same thing where we would have the intercept plus you know, that times t plus that times t squared for our new period. Well, let's go ahead and do the prediction. Okay, so it's going to be so we're going to have x here and our prediction here, and the prediction is going to be intercept plus actually we're going to need an x squared in here. So we'll put x squared and then our prediction. Okay, so and our prediction is going to be intercept plus this times whatever's x plus this coefficient times whatever's here. Okay, so that'll be our prediction. Okay, now notice we just have the intercept. So the period we're trying to predict with this model is 24. Okay, so t is equal to 24 and t squared is 576. So 24, 576. Okay, so this prediction now is 120.98. We'll just put that down. So this was our linear, this was our quadratic. Okay, so we tried two different regression models, and so far we like this one better. Okay, this one's probably closer to right. Okay. All right. Now, there are other ways of having a nonlinear trend in your regression. So as I said, if there's a straight line, you're just going to use a simple linear regression. If you have this pattern where you've got this curve that reaches a maximum or a minimum, then it's a quadratic. If you have a pattern that doesn't exactly follow that curve that has a minimum or a maximum, but rather curves monotonically down or up, then you have to capture that with what's called an exponential trend model. Now, I'm not actually going to make you responsible for exponential trend model, but I just want you to be aware that it is available and it does a good job of capturing and forecasting patterns like these. Now, you do have these growth and these decays like this. Anytime somebody says something is growing exponentially, this is actually what the growth looks like. And so remember that so the equation is going to look a little bit different. Remember that we had for the linear model, even if we were adding an x squared, we basically had this kind of linear combination of x variables, and then we had plus error here. So this was a line, so the linear combination of x or other x squared or whatever. But this is something that looks quite different, and this is not something that you can feed into Excel or any kind of regression software, but you can transform your variables so that you do have something that looks like a line that you can fit in there. So let's I'm just going to very quickly show you what you would have to do. So if you do have data that you think follows an exponential pattern and you want to use a regression to forecast, then what you have to do is this. So let's take the log of both sides of this. Okay, so we're going to have the log of y equal to the log of beta 0, beta 1 to the x. And then these are just our errors. I'm not going to worry too much about those, but okay, so the log of a product is this turns out to be the sum of the logs. So we can change this so that it is, okay, log of y is equal to, so it's going to be the natural log of beta 0 plus natural log of beta 1 to the x plus the natural log of the errors. Okay, and there's a property of logarithms that if you're taking the log of something to an exponent, that the exponent can be pulled out here. So we have the natural log of y equal to natural log of beta 0 plus x times the natural log of beta 1 plus natural log of errors. Okay, so now notice what we have here, that if we take the log of our y variable and then regress it on our x variable, this is going to be our intercept, right? And this is going to be what the regression software will give us back as the slope, right? So then all we have to do then is, so first thing is to, take the log of the dependent variable, and then you do the regression of the, log of y on x, and then you're going to get back, an intercept and a slope. To unwind this log of beta 0, you just take e to that intercept they gave you, okay, and that's going to give you beta 0. Then you have to take, to get this beta 1, you have to take e to that slope that it gives you back, and that's going to give you your beta 1, okay? So once you have those, then you can multiply them and then put in your new x, which is of course your period. Okay, so if you have an exponential trend, then you have to do all this. You have to take the natural log of your measurement and then regress the natural log on your trend, your period. And then when you get back that slope and intercept, you have to form them this way to get your beta 0 and beta 1. Then you can finally plug all this in and then do your prediction. Okay. As I said, that's not something I'm going to make you responsible for, but in your professional life, you may need it. Okay. So, the question then is how do you go about detecting whether something is going to be good for a linear prediction or a quadratic prediction or an exponential prediction. Now, usually you can do it just looking at it. So as I said, if you have a line, you can use linear. If you have a max or a min, then you can use quadratic. And if you have, growth at an increasing rate or decay at a decreasing rate, then you use exponential. But there's also a way that you can look up the sequential values and see, use the difference between those values as a way of estimating which, of judging whether you should use linear, quadratic, or exponential. And so the rule of thumb is just this. If the difference between the values, so the jump from 1 to 2 is the same as the jump from 2 to 3, et cetera, then that's a linear trend. So that's a constant slope, right? Okay. And you use a quadratic trend if the second differences are constant. So what that means is the difference from 2 to 3 minus the difference from 1 to 2 is equal to the difference from 3 to 4 minus the difference from 2 to 3. Okay, and finally exponential. So you can use an exponential trend if the differences are percentages of the lower one. So the difference from 1 to 2 divided by 1 times 100. So if these percentages are always the same. So if something grows as a percentage of its existing quantity, that's the definition of exponential growth. Okay. All right. So, but as I said, usually you can do those by eyeballing the time series. Okay. Now, the last thing we want to do then is, see if we can improve our Walmart revenue forecast by incorporating this obvious seasonality here. Okay, we've got these jumps here, that go down substantially in the from the fourth quarter to the first quarter, and we want to be able to put these into to incorporate this knowledge into our regression. So how do we do that? Well, we use dummy variables. Okay, so and then once we've added these dummy variables in, that will tell us how much we have to adjust based on what quarter we're in. Okay, so let's go ahead and make dummy variables. So remember that we have 4 quarters, right? So it's quarter 1, quarter 2, quarter 3, and we're not going to add one for quarter 4 because we're going to make quarter 4 the base case. So if something has zeros in quarter 1, 2, and 3, then it's in quarter 4. Okay. Now, rather than putting these in here, based on what's over here. So what I want is to say, okay, well, this is quarter 1. So that gets a 1 there, 0 there, 0 there. This gets a 0 there, a 1 there, and a 0 there. I'm not going to go and do all of this. There's a, if you would like to do this with me, I've written down the function here. And what this is saying is, if the rightmost character in this cell is a 1, then put a 1 in this cell. Otherwise, put a 0 in this cell. Okay, so what this is saying is, I'm just going to copy it. Okay, we'll start here. Okay, so if the rightmost character over here, and this is actually a 6, if the rightmost character is a 3, right? Well, it's a 3, but if it's a 1, then we want a 1 in this one, right? Because that means it's a first quarter. So that's right. So we'll put that there. Okay. Now we want to, I'm going to take this verbatim and then paste it over here. Except now I'm saying that if it's a 2, then put a 1 here. Otherwise, put a 0 here. Okay. So likewise, I'm going to come over here. Now, if it's a 3, put a 1 here. Otherwise, put a 0. Okay. So that this appears to be correct. Okay. So I just need to take these, okay, and then copy these down. Okay, and then we'll just verify. Okay, so that should be all zeros for fourth quarter, first quarter, right? And second quarter didn't get done correctly. So let's go back and see what's wrong with second quarter. We did the function wrong. So we just need to change this one column. So this should actually be the rightmost character is a 2. There is a 2. Okay, so let's copy that one and then paste it down here. Okay, so first quarter, second quarter, third quarter, fourth quarter, first quarter, second quarter, third quarter, fourth quarter. Okay, that appears to be right. Okay, so now we have dummy variables for all of our quarters. And okay, so now we're going to pull these dummy variables into our regression. And that will know, based on what quarter we're predicting, how much to adjust that prediction up or down based on what quarter we're in. Okay, so we'll go to, as always, data analysis regression. We're predicting revenue here. Okay, and now our inputs are no longer contiguous, so we need to fix this. Let's we don't need this column anymore, so we'll just take it out. Okay, now these are all of our dependent variable, our independent variables, so they're all contiguous, so we can select them. Okay, so data. Okay, so now we're doing all these. Okay, now look at what we have. So now we have an adjusted R-squared of 0.94. Okay, so now 94% of the variance in revenue is now explained by all these components. We're just using the long-term trend, which is encapsulated in that sequence, and then the seasonality, which is picked up by our dummy variables. Okay, so now we have a very, very good way of predicting revenue. We see that, of course, it's significant over here on the ANOVA table. And now let's look at the p-values, and the p-values of all of our variables is significant. Okay, so we need all of them. So now we have this predictive model. Now let's go ahead and do the prediction by applying this. Okay, so we're so let's so what we're going to do then, I'm going to just copy these coefficients to make this easy. First of all, let's make this easy to read by lopping off decimal places. Then I'm going to copy these down here. Okay, so that because remember that I have to do an equation where I'm going to multiply, I'm going to add this times 1, right? And then I'm going to, add whatever quarter I have over, I'm going to multiply this by the quarter, multiply this by whether it's a first quarter, multiply this by whether it's a second quarter, multiply this by whether it's a third quarter, and then add them all up, right? So that's going to be how I use this. So this is just a different way of applying the equation. You could just make it one long cell if you like. But so I'm going to do this times 1 plus this times. So what's the time period we're predicting? So we're going to be predicting time period 24 again. Okay, 24. And so this is going to be multiplied by 24. And what quarter are we predicting? So we're predicting, it looks like it's a first quarter. Okay, so we're going to multiply. So quarter 1 is equal to 1, right? Which means quarter 2 is 0, quarter 3 is 0. Okay, so I just need to that times that plus that times that plus that times that plus that times that plus that times that. Okay, so there's a really neat shortcut function in Excel called sum product, which will do exactly that. So I just need to select this and then select this like this, and it will do that prediction. So so that's just, remember that this is just applying the regression equation. I just took a couple of shortcuts there, but so 112.82. Okay, so we come back here, 112.82. Okay, so we're always predicting 2013 quarter 1, and so these are the various. This was our linear prediction based on just the line. This was our quadratic, which was not very good, and this is our seasonally adjusted. Okay, and so this one is going to be our winner. This is going to be based on that adjusted R squared. This is going to be the best, most accurate prediction. So 112.82, and so we see that it is going to go down, right, to over here. And that's because it's the first quarter. Okay. Okay. So that's how you go about doing forecasting based on regression.